So we left off here. We were talking, I think, about displaying additional information, which you can do in various ways, size, color, shape. So many different ways you can do that. But in a lot of circumstances, it's still, even if you have a lot of different shapes and trying to do a lot of different dimensions, I personally find that it's very easy, it's easiest to process oftentimes by taking slices of information. So instead of, so that means fixing certain values for your attributes, except for maybe 2 attributes. So fix all the others at various levels. And now take a look at what happens with those 2 attributes just by themselves. Because then you get an XY grid, and it's much easier to see how those 2 attributes are related. And then you can also do that by now adjusting all your other parameters one at a time to get a whole sequence of 2-dimensional graphs that then become easier to try to understand. So that's a lot. That's what I mean by slicing data. Another approach to visualizing data. There's some others that I'm not going to get to, but animation. You can, especially if it's a time-changing animation, you might have seen it with, for example, I think we had a graph earlier, a picture of sea surface temperatures using color. And I think there was that example, I'm trying to refresh everyone's memory of the polar vortex from last February. And you could see the cold temperature actually through the colors changing, plunging down into the eastern part of the United States. Anybody remember that graph that we had? I don't remember what day it was.
Was it the day that you went to the wrong classroom?
It sounds like that. It might have been. Okay. But so does that make some sense? You can actually visualize because it's a time-changing picture that way, and by animation you can see it happening in that way. Some additional approaches. Did we go over? I don't think we went over this slide. For higher dimensional data, you can use matrices. You can use multi-dimensional arrays. So think of a 3x3 or a 3-dimensional type of matrix. Yeah.
Or is higher dimensional data just data with like numerous attributes?
Numerous attributes.
Okay.
So parallel coordinates. So what I mean there, what I mean there is, can I get different? That's higher. Can I get different colors?
See where the pencil is?
Right?
No, go
Up.
right there. And then pencil color.
Right.
No, back. Pencil color.
So for example,
See if that changes.
you might have, see if I can get this one attribute going like that. And then on that same graph, you might then what happens to another attribute? And so on. And then you can get, so you're, oh, that's a bar.
Control Z.
Of course it wouldn't work.
Pencil. Up one more.
Wipe.
No, no, don't, just click the pencil itself. No. Your color's
Color's fine.
fine.
But I have to click on, no, click on the actual pencil.
There you go.
Something along those lines. And you can have, 20 different line graphs, each one representing something different there.
Have to ignore the paragraph.
Okay.
Go to slide. It should be one.
It's always like one prior. You can also use, star coordinates, and the idea there, so I'll again, go to the whiteboard here. Is you can have, say, each attribute, I'll just label them A, B, C, D perhaps, going in a different direction. So you could have an attribute going in that direction and actually using different colors can be useful here to demonstrate. And so my axes might be something in each of the four directions. So you might have your first attribute going along the x-axis, and here I did it in green so you could actually see the four different and you're going to get a different shape depending on how large the attribute is in each of the, say, four directions, right? So, I have red. So those might be the values of attribute A in green, attribute B in red, attribute C in blue, attribute D in yellow. And so then you would connect those points and the shapes are going to depend on the values. Oops, I should have just done a straight line there, but. So now you're getting the shape that I just drew there, right? And if your green attribute, your first attribute, had a larger value, it would be a different shape. It'd go farther to the right and so on. So it's just another way to visualize the data. So another approach is actually dimensionality reduction. So I think we sort of talked about that a little bit. Maybe you can reduce the dimension, reduce the number of attributes combining. I think we talked about the wind chill example. And that now by combining or reducing the number of dimensions, it's sometimes easier to see what's going on. So again, you can fix fixed values and just see what's happening within certain values. Pivoting's when you just basically doing dimensionality reduction and keeping everything except for two values. We talked a little bit about slicing and dicing and roll up and roll down. Basically, the slicing and dicing and roll up and roll down, you're kind of doing the same thing, except now you're doing aggregation in your variables. I'm not, yeah. I don't know, is that clear? Or should I explain it in a bit more depth there?
Good.
Cody, good? So what I really want to get to is this last slide, which is now you actually going into Weka and using the Weka itself to take a look at our visualizations. So I will stop this. Any questions in Daytona Beach?
Any other questions? No? Yes
So
or no?
now I want to share,
They can't answer the question, their mic's not on.
right,
No text error.
I don't think they're. He has no question.
so I'm gonna now bring up Weka.
It's rhetorical. It's rhetorical.
Any questions?
And again, the Explorer,
That is pretty good.
and I again want to bring up our weather example. Okay? And you remember the example that we had here, the weather example?
Right.
Because we're going to be coming back to this several times. So, what we can do within Weka is a lot of different types of visualization. And basically here, if you recall, we had 5 attributes. So, outlook, the weather outlook, the temperature, the humidity, and whether it was windy or not. And then the last one, play, we typically had as our class, we wanted, that was the goal here, was given the weather conditions, the decision is, do we want to play or not? So, notice I can set that attribute on the right-hand side, and that's what we're looking at right here. And basically, if you take a look at the actual data, so right now, it's selected, say Outlook is selected here, and you can start to visualize. So notice I've got 3 labels under the attribute Outlook. We've got sunny, overcast, and rainy, right? And what you notice down here is on the leftmost rectangle, you've got the 5, so I believe the blue is yes, you decide to play, and the red is no, you decide not to play. And so in this particular case, and we could check it by going to the actual data set, but you're seeing that when it's sunny, there's
There's 2 days of play.
okay, top 5 is the total number,
Yeah.
and there's 2 days to play and 3 not to. And you can see that here, if it's overcast, the total count is 40, and the decision has been made always to play there. And Similar, when it's rainy, you play 3 times and not the other. And you can look at these in various ways. Here, notice with temperature, temperature is a range, right? In fact, the temperature goes from 64 to 85 down at the bottom down there, and halfway in there is 74.5. And so what you see in this example, it brings up the median, the standard deviation of your values. But, so we now have 8 instances where the temperature is below 74.5 and 6 above. And notice, I think it's 5 and 3 choices or decisions to play 5 times when the temperature is below 74.5, and 4 times out of 6 when it's warmer than that. So that's one thing that we can do here to start off our visualization within Weka, but we can also combine, although I'm not sure. And we can also go up to this tab way up on the top at Visualize. And now what this is going to do, it's going to give us a bunch more options. So here what we can do is we can actually start looking at, we can do this before we do any processing or afterwards. So we can start, we have these 4 attributes, well 5 attributes. Outlook, temperature, humidity, windy, and play, and that's also going to be 5 attributes in the vertical direction. So play, windy, humidity, temperature. So we haven't done anything here, right? So what would you expect if you, for example, plotted temperature against temperature? Well, they're going to be, we haven't done anything, and you can also, if you want to make those point sizes larger, you can increase the point sizes just so you see it a little bit better. But exactly, you notice we haven't done anything here. Well, if you plot temperature against temperature, you're going to get a straight line 45 degrees. You can also adjust it up here. What about temperature versus, now, humidity? So notice here, remember the blue instances were the decisions to play and the reds were not. So we start to see whether we can make sense ourselves, whether whether there's anything we can see that might guide us as we go through the process of mining the data through the visualization. And at this point, you notice, so we're plotting on the bottom is humidity, and here it's going from 65% to 95%. Yeah, there might be a more, if you notice there's there's a little bit more of a instant of the red showing up as the humidity increases. We don't have a lot of data to make that clear, but the red seems to be more concentrated on the higher humidities. So, is that fairly clear? Yes?
Yeah, see,
Okay.
get on.
So that pretty much summarizes everything up to this point. We've done is, learn about your data, prepare your data, try to first understand what your data looks like. Is it binary? Is it continuous? Is it discrete? All of these different pieces, what your different attributes are. Try to understand You know, are there redundant attributes before you even begin? And then we started looking at some visualization. And so today we're actually going to move on. In the textbook 10, this becomes chapter 4. We're actually going to start data mining. Right? So at this point, we're going to begin with classification. I'm taking this continue with the weather example because it pretty much is going to be really clear to use here. So I'm going to get out of Weka for now and go back to the slides. And so we're now on so before starting, questions here, questions in Daytona Beach.
Again, it's rhetorical.
Oh, they're off. Where is it? Okay, no questions
Well,
there.
you already-
but
That was earlier.
that was earlier.
Oh, look, they have a little question hand thing. They got a question. Turn on their mic.
That might be from the old one.
That was from before.
No, well, 'cause they said no questions. So why did they put a hand up?
No questions there?
Thanks, Taylor.
Okay, thanks.
Goodbye.
So I'm going to continue on with decision trees. So, thought I made a change here on the slide. The approach we're going to use has a couple of different names. One is divide and conquer, or top-down induction. And basically, what we're going to do, we're going to do this recursively. And I'm going to go through some examples here. Hopefully I uploaded the correct version. But the key ideas are that we've got a whole, in the weather example, we have the one class, the play or not play, at the very end, and the 4 other attributes. Okay? And the idea here is we're going to choose one of those 4 attributes to start making decisions. That's why it's called a decision tree.
Makes sense.
Makes sense. And then with that attribute as the root, we're then going to use the other, use the classes, the labels for that particular attribute as branches. And then create branches for each of those values. And then we're going to recursively choose another. So after we've done that, we choose another attribute as our next node in the tree. So, and we're only going to use branches that are actually reached by the instances. So if you have a possible label but it doesn't have an instance that actually gets there, then you ignore it. So here's the example. There's one possible tree, right? And here I've used Outlook as the root. And I've only started as the first step in the tree, right? And so we've got the 3 possible labels. The Outlook could be sunny, overcast, or rainy. And below there, I've listed the outcomes from all of the instances. So the Outlook, when it's sunny, gives us 2 instances where it was sunny and 3 instances where it was not. We had overcast, 4 instances, right.
That's, the yeses and nos are to play, right?
The yeses and nos are to play, right.
Ah, I like it.
Okay.
You guys spelled the last name wrong.
So, right, so the yeses and no correspond to the class decision. And then what's another possible tree to start, possible first step in our tree, would be to start with temperature. And here we have hot, mild, and cool. And again, we have how each of those instances got classified. And so there's actually 4 possible root nodes. Here we have humidity. High is split 3 and 4. Normal is split 6 and 1. And the final, is it?
Yeah. It's,
The final one is windy. And just,
yeah.
and it says, and again, it was true or false. And again, you've got a split here. It's 3 truths, or 3 yeses and 3 nos when it was true, and what is that? 6 yeses and 2 nos when it was false. So you have 4 possible trees, and we haven't even gone to the next level. I mean, 4 possible root nodes, and we haven't even finished doing the trees. So this can grow quite rapidly if you have a lot of different attributes. So what tree do we want to use is going to be kind of the crucial question here. So, the idea here is how do we select the attribute upon which to split our decisions by? And so what we have to do is figure out some sort of measure of, it's sometimes called purity, sometimes also called information. And a couple of measures that we can use. One is called entropy.
Ooh, I like entropy.
Right, that plays a lot in machine learning and data mining in general. So we've got this entropy. I'll explain these in just a second. Another one is called the Gini index, and the third one is classification error. So here in these formulas, entropy is a summation over all the classes, okay, for that particular. So example, moving back here, I could have just gone back 1. So for windy, we summed over 2 possible classes, 2 possible labels, true and false. So that summation would have gone, C went from 0 to 1. Same with humidity. Temperature, there would have been 3 possible labels or classes, hot, mild, or cool. So there the summation would have gone from 0 to 2. So here I'm summing, there's a negative sign out front. P is basically the probability. And I'll go through an example, this example, times the log of the probability. That's basically an information measure. And when I talk about the log here, it's log base 2. Because we're looking for the information, basically content in
Is it
bits.
C to minus 1?
That's C minus 1. So that's a summation from I equals 0 to C minus 1. The piece of I, so we'll go through these in detail, log p sub I. And then a negative sign out front of that whole sum. That's going to end up a positive number because the log 2 is the probability is gonna be negative. The Gini index, the summation goes from the same, you're summing again over all your classes. Here I'm just squaring the probability, and I take 1 minus that. Classification error is a simpler measure. It's 1 minus the max over all the classes of P sub I. Now, I didn't put this into a slide. The text, I can draw these, but there's actually a lot of consistency, a lot of some correlation between these three measures. So for the case when you've only got 2 classes, there is a diagram in the text by Tan that shows how they are related. So I could draw those if anyone is interested, but suffice it to say, yeah.
What is the I under max? What is that?
That's the max of the max in all of your classes. So that's just a shorthand.
Okay.
So if you're looking at hot, mild, and cool, so that I'm going to look at the maximum over those 3 classes,
Okay.
which is largest. I'm going to calculate the P sub I for the hot case, the P sub I for the mild case, and the P sub I for the cool case. I'm going to take the largest of those 3.
Okay.
Other questions? So as I said, all of those 3 measures, they get at the same idea here. And they're fairly consistent with each other. So in what follows, I'm pretty much going to use entropy as my example. So let's go back, let's take a look, let's go back to Outlook as the root. If you recall, let me bring that up. With Outlook, in this first case, there were 2 yeses and 3 nos, right? So there's 5 instances. So my P sub I for that first case is the information of 2 out of 3, right? So, and we can actually, I didn't do that here, but it's in entropy it's going to be negative. Oops. It's going to be negative. What's P sub I for this case? 2 out of 5 times the log of 2 out of 5. And in the second case,
It's gonna be 4 and 4, so 1.
it's going to be
Negative 1.
-1 times log of 1, and Nick, what's the log of 1? 0. So the second case, and we'll see that, is 0. The first case I calculated, and that was what was on the other slide. And I also did the last case. We calculated the last case. Here it's information of 3 yeses and 2 nos. So there your probability would be 0.6. So 0.6 times log of 0.6. And then a negative of all of that. So moving forward, here are the actual calculations. So the information of 2, 3, 2 yeses, 3 nos, 0.971, 4, 0. We saw that. It's 0. So what we're really talking about here, we're going to start with I'll finish up with this. And then the info of 3, 2, again, 0.971. So we're interested in the total information oops, there's a typo there it's 5/14 probability log of, or the information of 2,3, so that shouldn't be 0/971, that should be 0.971. So p sub I times log. Plus 4/14 times 0, and 5/14 times 0.971 again. And you add all of that up, and you get that value 0.693 bits. Is it clear how this is being calculated?
And then we use that bits for,
Okay, well, right,
Yeah,
so probability,
so you need the negative sum of the probability log base 2 of the probability. You need,
right, okay, yes, negative log, 0.4. Log base 2 of 0.4 times 0.4, right? Plus 0.6 times log of 0.6. Right, because I'm summing over both classes.
yeah,
Yes and no. And that's why you actually have these being symmetrical here,
because it's 2 after.
because it's really the same. Does that, yes,
Got it.
okay. Sorry about that
No.
delay there. So moving on, I'm going to, whoops, we've ran out of time. So, but we end up with this 0.693 bits. So now the question is, now what? What are we gonna do with that? And we'll pick up with that next time.